This video is part of Firm Theory Production. In it, I will explain returns to scale. Returns to scale asks and answers the following question. How much does output change if a firm increases all of its inputs proportionally? So what we're doing here is we're imagining a manager walking into the firm one day and saying, look, we're going to scale up all of our inputs by the same proportion. We're going to use twice as many workers. We're going to use twice as much capital. And what we want to know is, what is that going to do to output? If the production exhibits what we call constant returns to scale, then what's going to happen is doubling all of the inputs is going to exactly double the output. On the other hand, if production exhibits increasing returns to scale, then what's going to happen is doubling all of the inputs will more than double the output. And if what is exhibited is decreasing returns to scale, then doubling all of the inputs will less than double the output. Let's look at this picture. What we see here is the production of typewriters. For simplicity, let's just say that typewriters are produced using two inputs. One would be the workers, and another would be the workstations. It seems plausible that if we use twice as many workers and have twice as many workstations, that we will see the production of typewriters exactly double. Doubling all of the inputs will double the output. In this picture, we see an assembly line. With assembly lines, again, it seems plausible that doubling all of the inputs, twice as many workers, twice as many workstations, capital, might lead to more than double the output because of division and specialization of labor. And then finally, in this scenario, we might think of decreasing returns to scale. Why? Well, because if all of the inputs are scaled up by the same proportion, then we might see things like a breakdown in communication, more difficulty in supervision of workers. And so for those reasons, we might see that increasing all of the inputs by one proportion leads to output increasing, but by a smaller proportion. But do note that with decreasing returns to scale, we do see more inputs leading to more output, but the proportion by which output increases is smaller than the proportion by which inputs are increased. In my experience, to really understand the math that's coming next of these concepts, you have to understand what each of these three represents. Okay, so I'm going to take some time now to explain these before I get to the example. Let's start with this one, F of L, comma K. This represents how much output's produced using the original amount of labor and the original amount of capital. I'm going to give you an example in the next slide. F of TL, TK represents how much is produced when both inputs are scaled up by T. So this is the original amount of output, and this is what output looks like after all inputs, which here is both inputs, are scaled up by T. Finally, this is the base of comparison. This is T times the original amount of output. So to summarize, we have first the original amount of output right here, how much is produced using the original amount of labor and the original amount of capital. This is how much is produced when both inputs are scaled up by factor T. So for example, if T is 2, this is how much is produced when both inputs are doubled. And then this is what we're going to compare output after scaling inputs to. So this is T times the original amount of output. All right, look, I know that's confusing, so let me go to the next slide. For example, let's say that our production function is the following Cobb-Douglas production. So right here, let's say that output equals the amount of labor times the amount of capital. And let's say that originally the amount of labor is two workers, and the amount of capital is one machine. What we're going to investigate here is a scenario where the firm is going to double both the inputs. So we're looking at a T that equals 2. Saying T is 2 is saying we're going to double all of the inputs. All right, so F of LK, again, is how much output is produced using the original input levels. So originally we have 2 workers and 1 capital. That's right here. So when L is 2, remember the production function, when L is 2 and K is 1, output is 2 times 1, which is 2. Now we're going to look at doubling both of the inputs. So we're going to double the amount of labor, we're going to double the amount of capital, and we're going to look at what output is produced. So we've got 2 times the original 2 workers, and we've got 2 times the original 1 unit of capital. And according to our production function, 2 times 2 times 2 times 1 is 8. So in this scenario, when both inputs are doubled, output equals 8. Now remember, when before inputs were doubled, output was 2. After inputs are doubled, output is 8. So in this scenario, when the manager walks in and says, we're going to double all of the inputs, twice as many workers, twice as much capital, what we see is output going from 2 to 8. That's an increase of a factor of 4. So here, doubling the inputs quadrupled the output. This right here, again, is a base of comparison. So what we're doing here is we're saying, what is 2 times the original output? Well, the original output was 2. So 2 times 2 is 4. In this scenario, doubling all of the inputs quadrupled the output, which is, of course, more than just double the output. Let me show you an example of how to mathematically determine the returns to scale for a specific production function. Here I want you to consider the Cobb-Douglas production function. F of L and K is L to the 2/3 times K to the 1/2. The first step in determining returns to scale is to plug in TL for L and TK for K into the production function. So here, where there's an L, I'm going to substitute TL. Where there's a K, I'm going to substitute T times K. So my production is going to look like this. TL to the 2/3 times TK to the 1/2. This is what actually happens to production when both inputs are scaled by T. We need to compare that with T times the original level of output. So we're going to compare that with T times the original level of output, which here would be T times L to the 2/3 K to the 1/2. The next step is the most cumbersome. We've got to do some algebra to try to see if the left side's bigger than, less than, or equal to the right side. Now the steps here aren't always the same for every production function, so that's where getting enough practice is going to be critical. But what I'm going to do in this example is the first thing I'm going to do is I'm going to distribute these exponents through the parentheses. So that here I've got T to the 2/3, L to the 2/3, times T to the 1/2, K to the 1/2. Now what I'm going to do is I'm going to just rearrange the order in which these terms appear. I'm going to bring these two T's together so I can more easily combine them. T to the 2/3 times t to the 1/2 times L to the 2/3 times k to the 1/2. And now what I'm going to do is, using my exponent rules, I'm going to combine the two t terms. T to the 2/3 times t to the 1/2 is t to the 2/3 plus a half. Well, 2/3 plus a half, what is that? Common denominator. 2/3 is 4/6, and 1/2 is 3/6. So these two t terms combine to t raised to the power 7/6. And then times L to the 2/3 k to the 1/2. At this point, I have a pretty good, I'm at a pretty good place for comparison. Again, I'm trying to compare these two things. And when I look at it, what I want you to see is that on both sides of the screen, I have the same L to the 2/3 k to the 1/2. So that's the same on both sides, which means the only difference is that on the left I've got t to the 7/6, and on the right I just have t. So essentially what I'm comparing is the t to the 7/6 with the t. For all of these exercises, we are scaling inputs up, so t has to be bigger than 1. We're scaling inputs up, so the factor by which the inputs are scaled, called t, has to be greater than 1, which then means that t to the 7/6 has to be greater than t, which is just t to the 1. So the left side, remember the left side, is what actually happens to output when both inputs are scaled by t, is greater than the right side, which is the original level of output scaled by t, which then leads to the conclusion that this production function exhibits increasing returns to scale. What actually happens when inputs are scaled by t is more than t times the original level of output.